Today I'll be talking about electrostatics. The three main subtopics in electrostatics are electric current, electric field, and electrostatic charges. The first subtopic I'll be talking about is electric current. Electric current is the rate of flow of a net charge through a certain region and will give a non-zero number. Therefore, if there is no current, or the current is zero, the net force will also be zero. Sources of electricity such as batteries that cause the current to flow one way are called direct currents or DC. In a direct current, electrons move from negative to positive. Sources of electricity that cause electrons to periodically change their direction are called alternating currents, or AC. This occurs in common household electricity among Australians. Current is calculated by using the formula I equals Q over T. I stands for current measured in amps. Q stands for electric field strength measured in newtons per coulomb, and time is measured in seconds. This formula can be used to find the current in things such as batteries. Next up is electric field. The magnitude of an electric field is known as electric field strength and is measured in newtons per coulomb. Electric field strength is found using the formula E equals F over Q. E stands for electric field strength measured in newtons per coulomb. F stands for net force measured in newtons, and Q stands for charge measured in coulombs. It is said that any region in space where there is a force on a charged stationary object that it contains an electric field. There are various formulas used in calculating electric field strength, but the most common one is E equals F over Q. Now for an example. What is the electric field strength if a charge of positive 5 nanocoulombs placed at that point in the field experiences a force of 2,5 times 10 to the power of negative 6 newtons? The equation you would use is E equals F over Q, and Q given in the question is 5 nanocoulombs. You convert this into coulombs, which is 5 times 10 to the power of negative 9 coulombs. The force given was 2,5 times 10 to the power of negative 6 newtons. So when you plug this into the equation and put it in a calculator, you should get 500 nanocoulombs. Next up is electrostatic charge. Electrostatic charges repel each other. when they have the same charge, but attract each other when they have different charges. Neutral objects can also attract other neutral objects, such as a charged plastic balloon and pieces of paper. Due to the principle of conservation of charges, charges cannot be created or destroyed, only conserved. A simple example of this is rubbing a glass rod with silk to give it a charge. The smallest amount that can be added or removed from an object is 1 electron, and this can never be changed. The charge of an electron is positive negative 1.6 times 10 to the power of negative 19 coulomb. The coulomb is the scientific unit of an electrical charge. Total charge is measured through the formula Q equals N times E. Q stands for net charge, N stands for number of charges, and E stands for the charge of an electron. Conductors and insulators can also help regulate movement of electrostatic charges. Thanks for watching.